All right, so let's solve this problem. Now, how many solutions, zeros, x-intercepts, roots, whatever you want to call them, how many of them am I going to have total? 4. Can we factor this one? No, there's 5 terms. We don't know how to factor 5 terms, do we? So we don't have a chance of factoring on this one. So let's use our p's and q's. So my p's are going to be the factors of what number?
13.
Okay. What are the factors of 13? 1 and 13. Because remember, p is the factors of the constant term, which in this case is the 13. What about q? What is my q going to be? The factors of what number?
1.
The 1, because it's the factors of that leading coefficient, right? And what are the factors of 1?
1.
Plus or minus 1. All right, and then P over Q, my possible rational zeros for this problem. How do we find them again?
Divide P by Q.
Divide all your P's by all your Q's. So I'm going to take my first P, which is 1, divided by the only Q I have is 1. What's 1 to 1? Yeah. What's 1 divided by 1? Good, plus or minus 1. Just don't forget it. If you don't say it, I'm going to assume that you're writing it, okay? Because it has to be written, though. All right, and then take your second Q, your second P, divide it by the only Q you have, so 13 divided by 1 is? So I have 4 possible rational zeros. I have positive 1, negative 1, positive 13, and negative 13. So I need to find the solutions, which remember is your x-intercepts, your roots, your zeros. So I have to pick one of those to divide by. Which one you want to use?
Positive 13.
Positive 13. All right, so we're going to use when x is 13. So remember, that's going to be the number that's going to go on the outside.
Well, we get to pick.
You get to pick which one you want to use. So, because we don't know which one's the right one. So we just pick one. So my coefficients, I'm looking at my exponents right now. They're all accounted for, right?
Yes.
So I have 1 x to the 4th. It was a negative 6x cubed, positive 22x squared, negative 30x, and then a positive 13. And what number do I want in my little remainder box? 0. All right, so I'm going to bring down my 1. Remember, multiply it times everything, or multiply everything on the bottom by the 13 on the outside there. So 1 times 13 is?
13.
Okay. Combine them. Negative 6 plus 13.
7.
Woo. Going to get some bigger numbers here. 13 times 7?
91.
Positive 91. So add them.
113.
Times 13. Y'all got to help me?
Not doing. They're in the calc. 1,469.
1,469. Negative 30 plus that. So 1,439.
Yeah, it's not
Times 13 is not going to be a negative 13, right?
No.
So I'm just going to put a big X there so we don't even torture ourselves with actually multiplying it out. All right, so you know what that means? We picked a bad number. No big deal.
Just do it again.
So we're going to pick another number, not 13, that's in our list. Now, guys, I didn't tell you this because I wanted you to see what if it doesn't work, okay?
I was going to ask you that.
But usually they're not going to be the really big numbers or like the really small numbers if you think about like the negative 13. They're usually closer to the center. Not always, but usually, okay? So I probably wouldn't pick positive 13 or negative 13 because that's pretty far out there from the number 0. So, okay, you want to try 1?
Yeah, I'll try.
All right, so let's try when x is 1. So my coefficients are going to be the same.
Is this being recorded as well?
Mm-hmm.
Awesome. I'm going to home and watch the film.
All right, so bring down that first number. Remember, multiply everything that goes on the bottom by that 1 on the outside. 1 times 1 is?
1.
Positive 1. Combine them.
Negative 5.
times that 1. Combine them. Okay, times that positive 1. Combine them. Times 1. Combine them. So we're happy, right? All right. So what I'm going to go ahead and do here too is I'm going to write above this my solutions. I already found that x equals 1 works, doesn't it? So now all I have to worry about is this right here. Well, what is that as a solution, as a quotient for my division problem? It's going to start with x to the 3rd, because my problem was x to the 4th, right? So it's going to be a 1x cubed minus 5x squared plus 17x minus 13. And so I just need to solve that part now. Can we factor it? No. Because my problem started with x to the 4th, and we always go down by 1 because we're dividing by x. So we go down by 1, okay? Every time we do that, we always take it down 1 more. All right, so I can't factor this. If I try to do factor by grouping, it's not going to work for me. But it's not quadratic either, so I can't use a quadratic formula. So what am I going to have to do? I'm going to have to do the same thing again using my p's and q's. But guys, we already did the p's and q's for the big polynomial. So if it works in that big polynomial, it's going to have to work in the small one here. Okay, so if it works with the one that started with x to the 4th, it's still going to have to work with the one that starts x cubed. So I don't have to actually do p over q again. I just need to pick another number from my list. So we already said 13 didn't work. Positive 1 did work, so let's pick another one. So negative 1.
Where's negative 1 come out of?
It's from this list over here.
okay.
I have to pick another one out of that list. Because my goal is I need to bring that largest exponent down to be x squared. Because then we know what to do with it. We can factor it or we can use quadratic formula. All right, so you said we're going to use what number? Negative 1. Now, when I go to do this synthetic division, I want to use the coefficients I just got in the previous answer. Because it starts with an x cubed this way, and my answer is going to start with x squared. So, use the coefficients we just found. So, my problem is now 1x cubed minus 5x squared plus 17x minus 13. So, those are the numbers I want to use. And what number do we want at the bottom in the box? 0. So I drew a pretty good big box there, didn't I?
Big box.
So we got, bring down your 1. Remember, multiply it times the number on the outside. Negative 1 times 1 is?
Negative 1.
Combine them. Negative 5 minus 1.
Negative 6.
Multiply it times the negative 1 on the outside.
Positive 6.
Combine them.
23.
Multiply.
Negative 23.
Combine them.
Negative 36.
Yeah. Even if you
What was your name?
didn't do it, we know it's not going to be 0, right? All right, well, that one didn't work. Now, honestly, I'm going to make sure I did everything right here, just in case. I think everything's good. So, we have one left, don't we? If this one don't work, we're in trouble. It means we made a mistake somewhere. And it's not one of them I would normally pick. And I warned y'all away from it, so I'm sorry. I said it doesn't work most of the time, but that doesn't mean all the time. All right, so same coefficients we just used. Because I'm still working on that piece right there, okay? The x cubed minus 5x squared plus 17x. Oops, I put the x, sorry. Plus 17x minus 13. All right, so we keep going here, and obviously our numbers are getting way too big for this one to work, right?
You're getting massive.
So that didn't work, but I still have to bring this down to an x squared. So what other option do we have?
Positive 1.
We can try the positive 1 again, because it could have multiplicity, right? So let's try positive 1 again. Use the coefficients, though, that we got after we did it the first time. So use that 1, negative 5, 17, and negative 13 still. And what number do we want in that box?
0.
All right, so let's bring down the 1 times 1, which is,
1.
combine them,
Negative 4.
times the 1.
Negative 4.
Whoops. Combine them,
13.
times 1. And we get 0, right?
First try.
So it did have multiplicity of how many? 2 so far anyways, right? So I'm going to come up here and put multiplicity of 2. And if it works again, then I'll have to change that. Alright, so now that we've got that, remember our answer coming out of here now is going to be, we started with x cubed for this one, so our answer is going to start with x squared. So I got 1x squared minus 4x plus 13, and I'm trying to find the zeros of that. So how am I going to do that? Can I factor it?
No.
But it's quadratic, so I can use that quadratic formula, right? All right, so make sure you have that written down because I'm about to clear the screen because I'm out of room. X squared minus 4x plus 13. All right, so what I had is our solutions. Should have probably just used my eraser. Were what? What did we say? X equals 1, multiplicity of 2. And we got to the point that we're at x squared. Help me, I don't remember. Minus 4x plus 13 equals 0. And we can't factor that, can we? There's nothing that multiplies to 13 that'll add to 4. So we're going to use our quadratic formula. So what is my A? What is B?
Where did that come from?
And C. Alright, so let's do our quadratic formula. Remember, x equals negative b plus or minus the square root. B squared minus 4ac all over 2a. You said b was a negative 4. A is a 1, C is 13, and A is 1. So negative 4 is good. Plus or minus the square root of. Negative 4 squared is positive 16. And negative 4 times 1 times 13 is, okay, negative 52.
Can we sing for extra credit?
All over 2 times 1 is, so keep going. So 4 plus or minus the square root of, all over 2. Can we take the square root of negative 36?
No, because it's negative.
Well, it's negative, but we also know about imaginary numbers, remember?
No.
So we got our 4 plus or minus. What's the square root of the negative part? It's going to give me that I. And so this time I'm going to rewrite it as the square root of 36 then over 2. But can we take the square root of 36?
Yes, I can.
So come on up here. So we get x equals 4 plus or minus, what's the square root of 36? So we got 6i all over 2. And can we reduce that? Yes. 4, 6, and 2 are all divisible by 2. So I'm going to divide them all by 2, and we get
2 plus or minus I squared 3.
not square root of 3, but 3i. So we got 2 plus or minus 3i, and we can say it's all over 1, but we know we don't leave it over 1, so just 2 plus or minus 3i. So that means I've got 2 plus 3i, and I've got 2 minus 3i is what x is equal to. So you said we had 2 plus 3i and 2 minus 3i.
And we have 4 answers.
Is there 4 answers there?
Yes, ma'am.
But I only have 3 written down.
One is multiplicity.
That 1 has multiplicity of 2, so it counts twice. Very good. So there are my solutions, my zeros, my x-intercepts, my roots, however they ask it, of this polynomial.